Hey guys, my name is Manan Sharma, and as a data science and business analytics intern in the Sparks Foundation, my third task was to perform EDA, that is exploratory data analysis, on a given data set of a sample superstore. So as a business manager, we had to try to find out the weak areas where we can work to make more profit. So our focus is to find those weak areas, and the tools we could use were Python, R, Tableau, Power BI, Excel, SAP, SAS. I had used Python here, so let's just see the data set. Alright, so this is the data set. We have columns like ship mode, segment, country, city, state, postal code, region, category, subcategory, sales, quantity, discount, and profit. So let's just see the code. So here we are importing all the required libraries: pandas, numpy, matplotlib.pyplot, cborn, and warnings to ignore the warnings. And here we are reading the dataset using read underscore CSV, and this is our dataset file, that is sample superstore.csv. And here we are getting the first 5 values from dataset using head method. Similarly, using tail method, we are getting the last 5 values from the dataset. And here we are seeing the shape of the dataset that we have. So it's 9994 cross 13. And here we are seeing the columns, all the columns that we have in the dataset: ship mode, segment, country, and so on. And info, just to get the data types, as we can see that some of the data types are object and some in 64 and some are float 64. Yeah. So here what we are doing is we are cleaning our data. So we are checking for any missing value. But here, as we can see, there's no missing value. So we don't have to worry about that. And now we are checking for unique values. So we are using df.nUnique. Alright, so now we are checking for negative values in our columns. So we are checking for each columns here, and then we are printing it, and as we can see that there is no negative value in any column except profit. So obviously negative profit means loss. So we have around 1871 negative values in the profit column. And now what we're doing is we are dropping the redundancy. So actually data redundancy is repetition of the data. So we don't need the repetition of the data, and it won't affect our task. So here we are checking for the duplicacy, and then we are dropping the duplicacy. Alright, so what we are doing now is actually we have to analyze our business. So we are using the group by method to aggregate, to associate two columns. So here we are aggregating ship mode profit, segment profit, city profit, and so on with the profit. So basically we are aggregating each column with profit. So we can see that ship mode wise, where is the maximum profit, where is the least profit, or and so on. Yeah. So as we can see, ship mode revenue, like ship mode wise revenue, as you can see that for same day it's 15891.7589. So it's the lowest. And for standard class, it's the highest. So this is the plot, and we are plotting the bar plot, and we have ship mode wise revenue as title, and x-axis is ship mode and y-axis is profit. So as here also we can see that on same day it's the least profit, and when we're talking about the standard class, it is the highest profit. So that's our conclusion. Obviously, least profit on same day and highest profit for standard class. And segment wise revenue, here we can see that for home office it's the least, and for consumer it's the highest profit. So now we are doing the same thing. We are plotting our bar plot. So the title is segment wise revenue, obviously, and x-axis it's a segment and y-axis is its profit. So as here also we can see that the least profit is at home office and the highest profit is on consumer. So that's our conclusion. Obviously, least profit at home office, highest profit at consumer. And here we are seeing the city wise revenue. So as we can see that Philadelphia, it's the lowest profit, or we can say the highest loss, and the highest profit is in the New York City. Alright, so here what we're doing is we are plotting the city-wise revenue plot, and we are using bar plot, and we are selecting 0 to 20 indexing. So as there are many cities here, and this is the city, these are the cities, and this is profit, and it's in negative, so obviously it's showing the loss, and the highest loss it's in Philadelphia, and then Houston, and then San Antonio, and so on. So the conclusion is highest loss in Philadelphia, and working on negative profit, that means losses would enhance the net profit, like obviously. Yeah. So now we are seeing the state-wise revenue. So this is the data. So as we can see from here, taxes in Texas, it's the highest loss, that means the least profit, negative value in 25729.3563, and the highest profit is in California, that's positive 76381.3871. So we are plotting the bar plot here for state-wise revenue, and we have obviously we have given the indexing 0 to 20, and we have x-axis as states, and this is the profit, and again we are seeing the negative values here. So highest loss, or we can say the least profit, is for taxes, and then Ohio, Pennsylvania, Illinois, and so on. So the conclusion is highest loss in taxes, and focusing on the states like Texas, Ohio, Pennsylvania, and many more, and acting on it would affect the net profit. So now we can see region-wise revenue. So we can see the central region is having the least profit, and the western region is having the highest profit. So we are plotting the graph again. So we have x-axis as region and y-axis as profit. So now we can see that the lowest profit is in the central region, and the highest profit is in the western region. So the conclusion we have is lowest profit in the central region and highest profit in western region. So now we can see the category wise revenue. So we have furniture, office supplies, technology. So the least profit is in the furniture section, and the highest profit is in the technology section. So we are plotting the graph here. So here we can see by the graph too that the least profit is in the furniture section and the highest profit is in the technology section. So that is our conclusion, obviously. Now we can see the subcategory wise revenue. So we have tables, bookcases, supplies, fasteners, and so on. So we can say the least profit, or we should say the highest loss, is for tables, and the highest profit is for copiers. So here we are plotting the graph. So here we can see the same thing. So the conclusion would be highest loss in tables subcategory and highest profit in copiers subcategory. Now we are seeing the discount revenue, discount wise revenue. Alright, so according to this data, if we are having discount as 0.70, then we are having the least profit, or we can say the highest loss. And similarly here, if there is no discount at all, then we are having the highest profit. So here we can see the same from the bar plot that we have. So the conclusion is highest loss when the discount is more, and highest profit when there is no discount at all, that is 0. So that's it for the task. Thank you.